Good evening. Today we are going to talk about compound inequalities. So, remember that based on this graph, we can determine that our solution must be x is less than or equal to 1. We can figure that out because we have a closed circle on 1, meaning that it must be or equal to. And since it's going in this direction, it means that it must be all things less than 1. So therefore, it's less than or equal to 1. So give this a shot, and that should be your first example. Write the solution to this inequality. So here we can look at compound inequalities, which is a sentence with two inequality statements joined by either the word or by the word and. However, we're going to be looking at it in terms of mathematical sentences rather than by words. So if we saw an or statement, what that's telling me is that it's a solution can satisfy either one inequality or the other inequality to make a sentence true. Usually that will look like two arrows pointing in opposite directions. It can have one or the other, a filled in circle or not. Whereas an and means that our solution must satisfy both inequalities. What that's going to look like is a line connecting two points. So let's take a look at some examples. So if we take a look at the next few examples here, we have a situation where we are talking about an or inequality. So if we take a look, we're talking about x is less than 2, which will look like so, or x is greater than or equal to 5. So you can see that I can satisfy either solution in this case, as there's that gap in the middle. And in this second one, we have an and statement. In this and statement, what this is really telling us here is that x is greater than -4, while what it's telling us here is x is also less than 7. And you'll see here in this example how that will look, because I'll have my -4 there, and it's greater than -4, so I'll point to the right. And I also have x is less than 7, so I'll go ahead and put that on 7. And the arrow will point to the left, and you'll see that they connect. So actually, I'm going to replace that with one solid line that connects those 2 points to show that both of those numbers, but that the solution must fall in between both of those numbers. By the way, the secret thing for this video is that the beginning of this video had a lot of feedback because I was recording in a cab. Alrighty, so moving on. Go ahead and give this one a try. And go ahead and take a look at these. So you'll see that if this is our graph for x is less than 3, and this is our graph for x is greater than or equal to -2, then the solution will actually look like this because it's the intersection of those points. So regardless of the fact that it fits for both, the intersection or the and is only within those 2 points. So the solution looks like so. Because right here, this is telling me that x is greater than or equal to -2, which is exactly what it says there. And this here is saying that x is less than 3. You'll notice that and solutions appear like this, as one inequality. You'll see that or solutions do not appear like that. So, for this one, try to write down what that would look like. Try to write down what that solution set would look like. Hopefully, you got this. Because this says that a is greater than -5, while it's also less than 0. So go ahead and try this one as well on your own. And let's take a look at this one. Let's say that we have an equation. All I would do is imagine that this is two separate inequalities. So I could say x minus 4 is greater than 5 and x minus 4 is less than 2. And now I can simply solve it. So I'll add 4 to both sides. And this is a -5, sorry. So I'll get -1 is less than x, and x is less than 6. Therefore, negative 1 is less than x, which is less than 6. The other way I could have done that is simply starting at the top and add 4 here, but then I add 4 to all sides. And I'll end up with negative 1 is less than x, which is less than 6. So hopefully that made sense. So go ahead and give this one a try. When you're done with that, go ahead and give this one a shot. You'll see here that we are talking about a union when we are talking about an OR situation. Because inequalities are containing OR is true if one or more of the inequalities is true, because it's a union. It could be one or the other. So if I had A is greater than 33,000, and here I have 0, and here I could have 33,000. It's greater than or equal to 33,000. Here I have it being less than or equal to 26,000. Let's say it's here. One too many zeros. And it'll look like that. The union will be somewhere between that and that. Either of those things can be true. So if you actually read this question, it says a pilot flying 30,000 feet is told by the control tower that he should either increase to at least 33,000 feet or decrease his altitude no more than 26,000 feet. In other words, this space here is the space that is not allowed to be flown within because it's causing turbulence. So that is the only place where a solution cannot exist. Therefore, as long as it exists within this space or within this space, it is a union and it works. So, taking a look at this question, go ahead and give it a try on your own. And let's take a look at this one. So we have, in this second question, right here, well not second, but we have on this question, two separate equalities. So I will go ahead and solve them separately. I'm going to go ahead and subtract 4 on this one. So I'll have negative 3h is less than 15. Divide by negative 3, which means because I'm divided by a negative, I'll have to switch my sign. Then over here, I'll add 3 to both sides. So I'll have 7h is greater than 21. So h is greater than 3. So if I wanted to graph that, I'll have 0, negative 5, and 3. X is either greater than 3 or x is also greater than negative 5. So that tells me that it can be x greater than negative 5 because anything greater than negative 5 will work. However, anything greater than negative 5 won't work for this solution. Therefore, h being greater than 3 is what our conclusion is, because anything that is greater than 3 will work for both of our situations. So go ahead and try this one and see what you come up with. And finally, give this last problem a shot. Hopefully that made sense. Don't worry, I will not be grading on accuracy for this assignment. I will instead be grading on effort on the examples. Do your best, and I look forward to seeing you on Monday.